See, in last many lectures on support vector machine, when data is mixed type and it is not linearly separable, in that case, kernel trick works well. And we have discussed some of the examples also. Now, today I am going to talk on variety of kernels, types of kernels. There are wide range of kernels and we'll discuss them. I will give you some figurative description. So let us see. See these figures. In the first figure, you will see that the data is quite linearly separable. Here, there are points of one kind, and here there are points of another kind. So this data is quite linearly separable. In this case, we require least kernel approach because your data is quite linearly separable. Now, if you come to the second figure, definitely second figure is not at all linear. It is something like a counter, geographical counter. It is a kind of a horizontal section, you can say. Right? Now, how to deal such a figure mathematically? That's a big question. And therefore, one can think that if you rotate this figure, it will look nicely as a normal distribution. And therefore, first step is one can think to rotate this figure in such a way that its look will be a normal one. Now, how to rotate? See, rotate means it's a kind of a transformation. So we have to adopt certain kind of transformation by which this figure will change its direction, and you will find that it's a normal or Gaussian type. And there is a standard Gaussian type of kernel formula, kernel function in the theory. So we have to convert it to exponential, the normal type. Let us come to the third figure. In the third figure, you will find that it's again a horizontal type of cut, horizontal section, you can say. Those who have learned botany, they know vertical section and horizontal section. So this is horizontal section. काही वेळेस बघा ते खूप मोठं रामफळ असतं आणि ते रामफळ विकायला कोणीतरी एक जण बसलेला असतो. आपण त्याच्याकडे बघितले गेल्यानंतर तो छानपैकी अशी हॉरिझॉन्टल स्लाइस काढून देतो आपल्याला. तर तो त्याला म्हणतात हॉरिझॉन्टल सेक्शन. आणि आपण जर त्याच्याकडे बारकाईने बघितलं त्या कट केलेल्या रामफळ म्हणतात का काहीतरी त्याला मोठं नाव आहे, रामकंद वगैरे असं काहीतरी. तर त्याच्यात तुम्हाला असे वेगळ्या प्रकारचे शेप्स पाहायला मिळतील. इव्हन झाडाचं खोड जेव्हा कट केलं जातं त्यावेळेस सुद्धा अशा प्रकारचे काही शेप्स पाहायला मिळतात. So these are the horizontal section. Now if you see this horizontal section, you will find that your data points may be divided into 3 sections. And they are not at all linear. So we have to think about some kind of transformation by which it can be converted to linear one. So in practice, we may get variety of shapes, variety of figures, and we have to apply our analytical mind by which it can be converted to linear. Of course, there are some standard kernels. We can start with them and we can think of modifying them. So let us come to the next figure. Let us see here. Let us see the first figure. You will see that there are three types of data sets. And among the three types of data sets, one type of data is quite separable from other two. That's a very interesting observation we can have. One type of data, for example, this one, for example, you can see this data. This is quite separable from the rest two data sets. And if you see these two data sets are little bit mixed. Little bit mixed means to this end the mixture is less. To this end mixture is less. But here you will find that mixture is well mixed, and we have a problem of classifying this type of data. Correct? So this is a problem of classification. Try to understand the level of mixture also, because the level of mixture also matters a lot. If there is a very heavy mixture, heavy points are mixed with each other, then there is very difficulty in separating them. But if very few points are mixed with each other and they are again on the boundary itself, then it is quite easier to separate them. When I say boundary itself, you can see this. This is a kind of a boundary. Almost all these points are to this side, almost all these points are to this side. So this is a well separable, and with little bit mathematical treatment, they can be quite separated from each other. Let us see this second figure, which is also same, that also depicts the same thing, that one data set is quite separate from each other, other two data sets are well mixed with each other, and they are likely to be separable, because if you see this, that is separable. Only we have to apply appropriate technique to separate them. Now, if you see the third and fourth figure, apparently seems to be same, but they are not exactly same, because if you see the background of third figure, it is uniform, whereas if you see the background of fourth figure, you will see that background also has two colors. It indicates a distinction. It indicates the distinction. That means this data maybe belongs to one category, and this data maybe belongs to another category. So even though they have same properties, still their categories are same. Here also, you can separate them and you can find that this is of one category, this is of other category. Whereas it is not the case. This full data is of one category, this data is of one category. So this is the importance of data visualization. Once you visualize the data, you will understand the pattern very properly. And understanding the proper pattern is the most important thing. Because once you understand the pattern, then definitely you can apply the proper tool. Okay. Now let us see here. There are two features, x1 and x2. If you plot the instances If you plot the data points, you will find that these data points forms a inner circle and outer circle. So they are circular in nature. And so these circular data points, are little bit too separate from each other. And therefore, if you apply a kernel, say phi, if you apply say kernel function phi here, which we have tried last time, if you apply this kernel phi, you will see that your data point looks like this. This is a plane of separation, separability plane. And below this separability plane, you will find one data set. Above this separability plane, you will find another data set. Now, in this transformation, try to understand one very important thing. Your original data is two-dimensional, but now your data is three-dimensional. If you apply the kernel trick, your data is three-dimensional. So you will see that there are three axes Z1, Z2, Z3. Earlier there were only two dimensions X1 and X2. But now, because of kernel trick, because of transformation, the dimensionality of data is changed from 2 to 3, Z1, Z2, Z3. In short, in many cases, we expect that transformation should be such that it will reduce the dimensionality. But SVM is the technique where we may go by both way. We may go by reducing the dimensionality or even increasing the dimensionality. So we have two options. So here dimensionality is increased, and because of increased dimensionality, you will find that separation is quite clear. So mathematically speaking, the points below that separable plane belongs to one kind. Points above the separable plane belongs to second category. That's as simple. And you know that equation of a plane is AZ1 plus BZ2 plus CZ3 plus D, or you can say greater than or equal to D, less than or equal to D, equal to D. When you say equal to D means you are exactly on the plane. When you say less than D means you are on the blue points. And when you say greater than D means you are on upper side of the plane. So that kind of distinction you can make. Now, if you take the reverse transformation, means reverse function, inverse function, you will again come back to the original figure. So you see here inverse function is applied, inverse transformation is applied, inverse kernel is applied, and you will see that these two images are same. Correct? So that is the property of kernel, that transformation will give you one set of data, and when that data is retransferred to original variables, that will again lead to the same data point, that will not change. So that is the means f of f inverse of x equal to x. That's kind of a property. F inverse of f of x is equal to x. That's kind of a property. Okay. Now, what are the different types of kernels? See, this is the uniform kernel function. So what this uniform kernel function says is, if your function is less than or equal to -1, you belongs to one category. If your kernel function says you are greater than or equal to 1, you are on the second category, and 0 is in between, that is the neutral value. Let us see this Gaussian kernel function. It's not exactly normal distribution as such, because if you adjust some parameters, you can get it normal distribution. But we don't want to talk about the normal. We want to talk about the shape of the data. And that is why when we have this kind of shape, we can apply kernel exponential minus norm of x bracket square. See, this is not simple x. If you have x vector x as x1, x2, xn, then you have to take the norm. And so uh, this is a kernel, Gaussian kernel. See, this is another kind of kernel, Eponchakov kernel, which is 1 minus modulo norm of x bracket square, where norm of x is less than or equal to 1. See, in this case, in this region, you will find that modulus of x, absolute value of x, norm of x is less than or equal to 1. That means this condition is satisfied. This condition is satisfied. And so whenever you are here, the kernel function says 1 minus norm of x bracket square. Right? So this is another kind of a kernel function. Now let us see what are the different kernel functions. Polynomial kernel function. So it's a polynomial means you can say a0 plus a1x plus a2x plus a3x plus up to a(n)x raised to n, where problem is to define what is called as power of the polynomial, degree of the polynomial n, and that will be decided by the data. Gaussian kernel I have defined. Then Gaussian radial basis function, Laplace radial basis function, hyperbolic tangent kernel, sigmoid kernel, Bessel function of first kind kernel, ANOVA radial Bessel kernel, linear spline kernel. So hundreds of kernels are there. Hundreds of kernels. I have just listed few, but hundreds of kernels are there. The point is that depending upon the data, you have to decide what kind of kernel one should use. And in Python, there is a big library where SVM is already coded, and with minor change of your data set and your kernel function, you can try variety of examples. So with this, I am going to end up with the lecture on kernel now. We will start from next lecture another topic.